good morning, everybody. Today we are going to cover the application of, in the beginning, the application of awk and bash, let's say, for manipulating the string text file. And I will give a practical example in the HPC using the login node, using the terminal, so without submit a job or something like this. So it's like working in the virtual machine. Unfortunately, we cannot really do it in the virtual machine because the files are quite big. But this can be is already on the web. So if you go to the web page, please always refresh several times. And also with the button over here, you can, because sometimes is, like I mentioned to you, the cache is not refreshing. And so if you're scrolling down over here, you have the manipulated GSIM files. Okay. So I don't know if you if you had the opportunity to download this file. If you don't, do it or do it later. I mean, it's a good file in terms of very well done file in terms of structure. So everything is organized properly in terms of nomenclature. All the files are inside all the same. So it is quite good for didactical purpose, and they are quite a lot. Okay. So now I did now I'm directly in the login node of the HPC. Whenever you enter in the HPC in HPC, you enter as a terminal and you have the so-called login node. So over here you cannot really do it massive process, but what we are going to do it is data exploration. So, and will not use a lot of memory, RAM, and so on. So it's possible to do it. And also because if I build up a job, we don't see the output, so it's a bit more complex. Okay, perfect. So the GSIM files you can download it directly in this web page, and you have these two publications that are dealing. They tell you what they are, how they have been created. In particular, let's see the structure by making larger to see better. So in particular, these are MON. So as you can see, the MON extension does not exist in particular, but we know that it's a text file, okay? So in particular, over here, you can put whatever you want, okay, as an extension. It's not something that the computer recognizes, or it recognizes to say, okay, there is a TXT extension, so probably it's a text file. And maybe I can open with a text editor. And the same for TIFF. There is a TIFF, so probably I can open with OpenEV. But this one can be anything, So just a string of the name. So in this case, the author put MON because it's monthly, okay? So this one is a text file that representing the discharge, so meter cubic per second in a particular station. So these are the coordinates of the station, and they are referring to the water stream. So this nothing else is a station that is taking observation every day, but then the author has been aggregated the observation every month. Okay, and we have meter cubic per second in the full months. And the beauty of this is that you have you have the date. So okay, over here you have the name and the river, but something extremely important for us in latitude and longitude. Okay, and they are in degree and in decimal, yes, with decimal information. Then we have we have the date. As you can see, they go every they have the day, but the day is just the last one. So they go every month, you can see. And you can have the mean, the standard deviation, coefficient of variation, interquartile range, minimum, maximum, and so on. So for some station, they have an A, so they have been not recorded. Rather, for some other, they have been all the variables, okay? So we will play a bit with this data, and we will see how to enter it. So these data are quite long. So, and of course, interrupt me if you have any question that is not clear. Anyway, it's a text file with what? With comma separated file, okay, with a comma separated file, and we will try to deal and play with this one. So sometimes they are so big and so huge that is also take a time to list it, okay. Actually, now if you list it again, it's going to be faster. But if you list the first time, it's quite slow. So something very useful when there are many files, and these, how many there are, like more than 30,000. So they start to be, so I can pipe, like we mentioned before, and we can say that are more than 35 files. So something very useful, rather than listing, you can do find. Okay, find allow you to have a faster visualization of the file, and sometimes even if you do, one second, let me try. So if you go back one line, so if you go back, for example, over, yes, if you do something like this, okay. Okay, so now, for example, I'm listing I'm doing the same, okay? So as you can see, it take a while, sometimes it can be even longer. And you can have also some warning that say the list is too long, I cannot list it. This is happening when the file start to become 50,000, 100,000, and so on. So with the command find, you can list also very many of these files. So the find command is also very useful to search for particular pattern in the file name. So for example, here I can do find dot. The dot means this directory, minus name, the dash name, okay? And then I can say all the SU, all the, sorry, United States file dot asterisk dot mod. Okay, so in this case, it's going to list. Oh, in this case, you need also the quotation. Okay, it's going to list only the file that are starting with US, and then they have the ID. So this one is also, in this case, is the ID of the file, and is also the ID of the station. Okay, so so we did a bit of data exploration, and let's see how we can play and take information about this file, and how we can, let's say, convert it and play with their geographical information and with the data in general that are stored here. So, for example, as we see,
Can I ask a question?
yes, please.
Yeah,
So,
I can't. I cannot download the file. It sort of gives me an 404 error, like not found.
can you? No, okay. Yes. 1 second, guys. These are not present in the virtual machine.
Okay, okay, yeah, I
Okay.
guess, yeah, sure.
Yes, that's why I send in the Slack channel to download in advance. Okay, with
Mhm.
this. So again, if you go over here, if you go in the manipulate GSIM file over here, you can arrive to the web page, and you can, no, it's not coming here. And you can, oh, I have to click here, and you can download the file. So
Yeah. I meant these things. I did that WGET thing, but the web page is not reachable.
okay, yes, again, when, because every web page in general store the cache, is called, and some cache are fixed in your computer, so you have to refresh several times. Okay, so if you click over here and you refresh, also you click again, so then you will see that this one is going to appear. Okay,
No, I have the web page. Okay, if you press the control and refresh the page, it sort
yeah,
of brings the new cache of the web page. So we have the web page, but when I do like the wget in terminal, I get like a page not found. Actually, it can connect, but the HTTP requests and response is
Okay.
like not found.
Um,
And I also did copy that that thing in a browser too. It's
yeah, it could
like the
be.
same message.
Okay, yeah, this one was a link like 1 month ago. Lonzo, maybe you can go and take a look where the GSIM is located and
Okay.
give us the new probably the new HTTP address for the zip file. So if you
Okay.
search for the web page, it will give you directly where to go. Sorry
Okay.
about that,
Sure.
but
No
anyway,
worries. Yeah.
we can find we can play and I can show you. I downloaded 1 month ago or 2 months ago, and then I didn't check yesterday. Um, so what we can do it is, for example, we want to create a X and Y text file with the coordinates and see where they are at the station. Okay. So something very good, for example, we can count um, first, we can count the month, for example. We need to be always sure that, for example, um, what we are going to do it is correct, let's say. So let's see some potential mistake that they come because the file are all together, but we don't know, I mean, all together. They are all the same, but we don't know. There is always lat long, they should be, but something can miss it. So what we can do it is, for example, count number of file. So WC-L. Uh, uh, sorry. So we can count the number of files. So we have 9404. So now let's see how many latitude we have information. So we can do perfect the same by wrapping the latitude information. So what I'm doing, I'm getting, and now we will see. Okay, so I'm getting in all the files the information about latitude, where we have in the file we have the word latitude, and we will open again, and I'm also counting how many there are. So now, as you can see, this information is quite, this process is quite long, because what it's doing is reading all the file that are under United States.mon. Okay, and this count how many there are. So if this information is correct and I retrieve the same number, means the latitude column is always full. Okay, so this is something that is quite handy in this case. As you can see, it's taking a while because I'm checking 94, sorry, more than 9,000 files, and is grabbing this information. So in particular, it's very common also in this case to work with two terminal open, and I strongly encourage you to do it quite often. Um, this way you and I mean, also in the virtual machine, you can, in the meantime something is happening, you can do something else. So that one is inside here. JSON, JSON, okay. Okay, now I'm in the same, so and I can check you what is doing. Okay, perfect. Now it's over. So in particular, what I'm doing with that line is I'm getting the information of this one. I get the one that is very long. So with this AWK line graph, I'm getting this information, this text file. So in particular, I'm searching for this word, latitude, and then I'm printing, 1, 2, 3, and 4, the 4 column. Okay, and the 4 column is giving to me the number. So in other words, if I rerun this line without the W count, I can print just the latitude information. Okay, so as you can see now, it's much faster. So I do the perfect the same by counting also the longitude, And this gives to me that if all the latitude and longitude are the same number, means that no entrants are missing. Okay, so now what I can do it, and this is the typical operation that you can select, you can do it oak. So to reply to Alexandra, so oak is not is for text manipulation. Let's say that you can do whatever you can do it in Excel and in Access, let's say. So multiplication between columns, sort, yeah, if condition for a specific column, um, whatever you do it in Excel, let's say. Why we do it? Because it's extremely fast and is very good for squeezing the data. We really call it squeezing or summarize the data, the text file, always text file, before importing in Python or in R. Okay, so due to that, it's very process efficient. There is no RAM limitation. Has been built by the people. Actually, this is the abbreviation AWKR, the abbreviation of the surname. Now I don't remember them, but that build up the C language. Okay, so and actually the syntax is very C oriented. That's why doing the shift between oak and C is quite straight. And so these allow you to also to play a bit. For example, if you want, like we were see before, we were see last time, this one is printing, for example, all the coordinates. Okay, so this is printing all the coordinates. You can play, okay, rather than having the full digit, I have 2 digits after the colon. So you can use the printf, okay, function with the, so you put between brackets everything, and then the first element is giving to you information about the format of the number that you want to print in this case. So in this case, you put between brackets, and then it's quite, you put the percentage that identify the kind of format, and then the F. Okay, F stay for floating. So in this case, is going to print the full number, and in order to go to the next line, you can do \n, and \n is giving to you the next line. So over here you can play. Over here you can say .2 means that I'm going to print only the 2 decimal place. Okay, so this is what you can do it with oak. Just Google it, this format. Sometimes I also don't remember. I use quite a lot the floating to make short or longer, but there are plenty of these kind of printf function that you can use to identify the format of this number, or also of a string. You know, you can say, okay, the first 3 characters of the string. So these are what you can do with oak, every kind of text manipulation. So now that we are able, let's say, to, and we are sure that latitude and longitude have the same number of observation, and they are also the same number in the file. Now what we can do it, we can get these two. So in particular, I can get this line. So let me copy like this, in this way you see better. So you can get this line, 1 second. So here you can also use this one to go to the other line. Okay, so like this you can see better. So you have 2 information here. You have 2 patterns. Okay, here I miss one sign over here. I forget it and paste. But anyway, we'll give me an enter, but an error, but I will paste. So this one is giving to me the column for the longitude. Okay, just the column for the longitude. This one is giving to me the column for the latitude, and I have the 2 columns. And then the command paste is giving to me the union between the latitude and longitude in a paste function, and the -d identify the separator. So in other words, is doing nothing else than this. Oh, okay, was working. Nothing else than this. So it's giving to me the x and y coordinates of each station. Okay, so you can even, let's see if it's true that this one of these are correct. So what you can do it is you go back to the United States. So for example, you do United States, you do grep, and you grab one of these number. Let's take out the dash. In this case, you have to put the escape. So actually, let's take it out. I think you need two, or maybe like this. When there is the dash in front and the minus, it's always a bit. Okay, so now you can see that longitude, for example, is grabbing this file. So we can even enter in this file, okay, and see if we have the other one. So 509 was this one, and the last one is 504, okay? And we can see if the second one, this one is always the long one, okay, the 504 and 509. So is getting the right information. So by this line, what I'm just in a really fast way creating my X and Y coordinate, okay? X and Y TXT file. And then what I can do it, okay? So we'll do probably today or tomorrow, I think. There is also another really nice software implemented already in the Bash, that is NewPlot, okay? So NewPlot allowed to do really, really fast, much faster. I use it for data exploration. My plot, the fancy one, are done in R principle mainly, but for this kind of fast exploration, I use quite often NewPlot. And NewPlot, you just do plot using column number 1 and column number 2. Okay, so you can see immediately that you have United States over here. Okay, so this is the beauty of having rather in R, you should load the library, open another Windows, and so it's a bit more complex. You build up the R script when you want to do the plotting, the final one, let's say, not for this kind of data exploration. So you can immediately see that I have I have the continental one, but I have also the Alaska and the Hawaii, and these are probably Puerto Rico or something. And eventually you can do an if condition with the coordinates and plot. And over here you do an if condition in oak and giving just the bounding box of the continental United States. Okay, so these allow you to give really a fast look of the data. So this is a kind of manipulation that you can do. So another example, for example, you want to count the number of observations. So back to the file. So this file, we know there is, for example, there is many points that you have NA, okay, that no information. Rather, in other dates, they don't have NA. So are they going to be a lot or not? So let's make an investigation about this. So this is the typical data exploration. So what I can do it is first count the number of $2. Okay, I think it's going to be fine. I'm going to get number 2, column number 2 over here. Okay, and in particular, what I'm going to do it here, how many, I'm going to use a tricks, and in particular a variable in AUC that is the number of field. So over here, I can see that this information has, let's say, 5 field, and this other information is quite long. Okay, so what I can use it the number of field, that it means number of column. So if my number of column is bigger than 5, so I'm concentrating on this, print $2. Okay, I'm printing this one. So let's see what this part of the command is doing. Okay, so to get out from less, you need to press Q. Less is good because you can go up and down in the text file. So over here you can do Okay, so yeah, so let's say decompose. Oops, let me break this command in this way you understand. So let me do like this. So this one is printing to just column number 2. Okay, so up to here is printing just column number 2. Then what I can see that I have also date, because column number 2 there is also um, I can, yes, there is also somewhere, sorry, not number, yeah, print number, there is also the word mean. Okay, actually over here I make a mistake, it's not minus b, it's minus. So now I can take it out mean over here. So I do the same, but I take out mean. So grep dash b mean. So now I can list again, and my mean will be completely disappearing. And now I can count, okay, how many observations I have. Boom. And will be a number, actually, it will be a slightly different because I grab the date and not the mean. So at this point, I know all the observations that have the data, the number, this number, but also the NA. So I have 60,000 million, yes, over here. So now let me do perfect the same, but avoiding counting only the NA. So what I do perfect over here, I do the same, but rather than grabbing I can grab the information for NA. So now I'm counting how many NA I have. WC cash. Okay, so now I can see that it should be the same number now, this one. So, and this allow you to have this fast exploration of the data, much faster than Python. In Python, you have to load one by one, looping through the looping one by one, and then looping also inside to the file. And also, when you load it inside to Python, they are going to be in the memory. You fill it up the memory. Rather, for this kind of data exploration, are quite fast in this context. So again, the difference is because I make a mistake over here and put in date and not mean. Okay, so is it clear the kind of operation that we can do it with the hook and so on? Alexandra?
Yeah, that makes sense.
Okay, perfect. Yeah. So we can also do it something very.
I have a question.
Yes, please.
So in this example, you use NF a bit larger than 5 because you want to skip the first 5 lines?
Perfect. Yes. A number of field. Yes. Number of field, because over here, very good. Over here, I have, I have less number of field. So I want to concentrate only in this, again, sorry, in this part of the data set that has more than number of files. Okay. More than, sorry, not number of files, number of field, more than 5. So I can concentrate in this one. So I get rid of all this part, and then I'm going to select just column number 2, okay, and keep in progress. Okay, so pay attention over here that here my space separator is the comma. So as I mentioned last time, the default in the Linux environment quite often as a column separator is the space. So I need to inform Oak that my field separator, and I do it with this -f, comma, is the comma. Yes, is the comma. So and then I can tell you, I can tell whatever it's doing. Okay. So in this case also, I use another trick, for example, to count how many observations I have for each single date. In other words, here I have this date, and also in another file for another year, I will have no, sorry, in another station, I will have the same observation. So I can get this information and count how many observations I have for a specific date. Okay, so these are extremely important because I can understanding how my data are distributed and so on. So what I do it in this case, I get $1. If I say if $1 is bigger than 1, is bigger than 0. Why I do bigger than 0? Because this is a number, okay, even if it's a date, the computer doesn't know that it's a date, but it's starting with a number, okay? So doing bigger than 0, I avoid to have date inside, okay? And then I can say print $1, okay? So this one, in other words, is, we can try to do it like this. So this one, for example, is printing only the date, okay? So now it's printing only the date for one file, but as soon as I put over here the asterisk, I can list for all the different file, for all the different stations. So I just print $1, okay? So at this point, what I do, I sort in them, okay? It doesn't really mean which kind of sorting. We can put the -G to have numerical sorting. So now what he's doing, okay, first of all, it's taking a while because he has to first print in the RAM. So this now they are stored in the RAM, all the information from printed number 1, and then sorting. So also there are these two operations are quite long, you know. So it will take a while to sort it. So the same kind of observation, for example, if I enter here, I can play a bit. So, okay, I am here. So the same, perfect same command, in other words, to see what it's doing. So if I was, yes, so now it's sorting. So as you can see, it's sorting. So I have all the 3402, 28. Okay. So now what I can do I can do the unique. The unique -C that identify the counting. So now is after the sorting is make unique. So all these one they become only one line and is counting how many I get. Okay. So this is really handy to see how my data are distributed. Okay, in time. So are more often which are the most common, and we will see the pattern of the file. Okay. So, and of course, I can redirect directly to a file that is counting the number of dates. So this allows you to have a fast understanding of the file that later on you can open. So let me do the same operation here. In this way, I can have a file. So now it's the same operation, but I just have a file. Over here now you can see that you have, you know, the date and the counting of observation for each date. Okay, so you will see that in the beginning, because there's some they started more than 100 years ago or something like this, you will have few information, then it's becoming really dense, and then again few information because maybe the data set was not updated on time and so on. And these are very important because later on you can do some statistical analysis. Is very important, and Lonzu is going to concentrate a lot in explaining how is important to understand the data distribution and so on. So this is, in other words, is my file that is sorted. So more that is starting from, as you can see, quite a lot, and as soon you go more in time, so it really start more than 100 years ago. So whenever you go down, so probably you will have, when we reach the war, it's going to be very low again, and then it's going to increase as soon we come, let's say, to our age. So this is super handy, this kind of manipulation. So another one, for example, you can do something very similar with understanding the mean. Okay, so you can do something very similar, but rather with the date, you can understanding if your data, this is the new one. Yes. So if your data is normally distributed or not. So rather now, for example, rather than getting the date and getting the mean of the variable. So what I do it over here, I do something something fancy, not fancy, but a bit trick. So I can get a file, for example, again, to let you understand. So just one file, ls us. Okay, so I get one file. So what I do over here, I do perfect the same. I get column number 2, that is then my mean. I say if it's bigger than 0, in this way I eliminate all the NA, print. And over here, okay, what I do it over here, I'm printing just, I don't print, let's say, all the small number, but I print only the integer. Okay, so by printing only the integer, I concentrate my information in only the integer part. In other words, these two information will count as a 1, as a 2 of the two, the same value. Okay, so at this point, I can do perfect the same with my with the full data set, and I do the same after making the integer. I sorting and then I count. So this one again will take a few seconds, and we will see immediately that our data, they are going to be skewed to the left. In other words, we will have a lot of rivers with a very low amount of discharge and very few with a large amount of discharge. And this is the case where you have only few big rivers like Mississippi, Rio de Amazonas, and so on. So as you can see, you have over here, you have the discharge to the right, and here the number of observations. So if you go back the column, so you can see that as soon as I go up, my number of observation days increase, and I can see that actually the one with a really low discharge are very many. So what does mean that my plot is skewed to the left. And also in this case, you can do again a plot with a new plot to understanding very everything. So consider now that we are doing this only for United States. Okay, if I just do this, I can do for the full 30,000 file. Okay, will be a little longer. I just put United States to have a fast result, but this is how we usually work in Zoo in this kind of data exploration and understanding the pattern of the file. Okay. So any doubt about this question? Do you think it's useful? How usually you do it in this kind of operation? Or yes, if you were doing before in Python or in R, did you see the improvement, or can you see the advantage? This kind of feedback. And then Lonzu, I don't know if you find the URL for downloading the data. If not, I can do it before, after.
I think it's posted in the chat already.
Okay, great. Yeah, thanks. I have to put the chat in. This is one point. Anyone, any suggestion?
Well, I would say that what is cool here is that in one command, more or less, you can do like things that would probably take several lines if it was, for instance, on R, I'm thinking.
Perfect. Yeah.
So it makes it really efficient, I think. Once you master the language and you know which words or commands to use.
Yeah. Yeah, these commands are really in nesting a value. Let's say if you understand, you know, okay, I need to print only few columns. Okay, I can use awk. Then I need to sorting, and you know that there is a sorting command. And then you say, okay, now that it's sorted, I need to do the unique because it's compressed. Actually, the unique I discovered quite late. I mean, when I started many years ago. But all these kind of operation are really, they already have tools, you know, you just need to search it and you will find, if you say, okay, I want to have a unique value in my columns, immediately will come up the unique command in bash, okay? Or for example, the other day Lonzo was showing in Oak how to do the block file, how to split one large file in many small file, but there is also another command that is called split that does perfectly the same. So if you just Google it and you do bash Linux and you do, for example, the join command, I don't know if we see so many applications, actually not so much. A join command is very useful if you have two tables with the same ID, okay, and you want to match. So ID 1 with ID 1, even if they are not in the right position, you can match. So that one is very common. It's super fast in this kind of application. In R, there is this other library that I always forgot the spelling and the name, but it's tidyverse or tidyverse or something like this. That is for table manipulation. It's getting better, much faster, but we still prefer to do this kind of pre-cleaning and with bash and Oak, and then having clean data inside inside R and so on. Because when you start to have these are 4 gigabyte. These are 4 gigabyte. This full, in particular, you can do like this. You can do du minus s minus h, and you do month. So it's 4 gigabytes of data set. So it start to become quite big. If you bring everything, all this data set inside R, your memory is full, especially if you are working with a laptop. Okay, laptop has from 8 to 16, maybe you have 32, but then it's full. So why bring in data numbers that you are not going to use it? If you need to use only 2 columns, you can clean your data set. You can maybe get rid of the station information on the top and then enter just with date and column. And over there, you can do more fancy stuff, standard deviation, because there are also ways to calculate standard deviation with Oak, but then it's becoming many lines, the code. And frankly speaking, in the past we were using, but now Python and R can do it in easy way, but at least you enter with very the small data set. Okay, so good. Society found the. I will update. I will update the web page with the right link in the for the Pangea dataset. Okay. Any other question in this direction? Do you think that will be useful? Who is dealing now with a bit of large TXT file? Let's say Marianne. And which kind of data you are using, Marianne?
So I'm using acceleration data, meaning
sorry?
I'm using acceleration data.
Acceleration.
It's more or less collars that I've put on reindeer, and they measure movement, and it's in hertz, meaning I have 10 data points in 3 dimensions, in 3 variables per second, and this over months. And I have like 30 reindeer. So every logger would have like around maybe 10 gigabytes. And the first thing that I would have to do, because I want to do some analysis on it, and that the analysis I would like to do it on air, is to actually split the data so that it's actually readable in any way. And actually, it's true that I've done it in Python before to split the data, but now I think with Oak, I would really do that much faster. And yeah, so that's kind of data I've been trying to deal with lastly.
Okay, very good. Thanks, Marianne. Anyone else is having some kind of similar? Yes, Alex.
I don't know if that microphone works here. Do you hear me? Yeah,
Yeah.
okay. it's on the webcam, never used it before. Yeah, so I don't really use that kind of data right now. I use more like reanalysis data sets, which are mostly rasters or
Okay.
PDF files. So I think for that, ORC is not the best solution. But
Yeah.
in general, I think it's a really nice tool to get stuff done very fast, especially because you can export that stuff to an Excel file and then you can read that into Python. The only thing for me, I guess,